Okay, for this introduction video, this is actually not something that's in your notes. This is just something that I want to go over with you guys to give you an introduction to two-step equations. So this example problem here, it wants to know what is the mass of 7.09 times 10 to the 24th atoms of helium. So we're still going to underline what we're given. We're going to circle what we're looking for. If we take a look on this infographic, this picture up here, we were given particles because we were given atoms of helium. It's asking us what the mass is. So when we go to look for this and we try to figure out what the connection between particles and mass is, there isn't a conversion factor that's actually given there. There's not a connection between those two. So when you have something like that, what you need to do is you need to do a two-step equation. You were given atoms, so you need to convert from atoms to moles, and then from moles to mass. So over here, since we don't have a conversion factor that directly links mass and particles, we need to do a two-step equation for them through the middle. So our first step in this is we need to figure out a plan. We need to figure out what our steps are actually going to be. So what we were given is atoms. Now, the only place we can go from atoms, which is all the way up here, is the only connection that we have. The only place we can go on this map is down to moles. So we're going to have to go from atoms to moles. Now, from moles, we can go a lot of different directions. From moles, we can go to particles, to volume, or to mass. So what we have to think about is what we're looking for is mass. We already wrote this out in the beginning that we need to go from atoms to moles down to grams. So if we start at atoms, our next stop is moles, and then we can go to grams last. Your last step should always be your unknown. So your first step is going to be what you're given, your last step is going to be unknown, and then whatever comes in between. So at this point, now we can set this problem up just like we've set up all of our other problems that we did that were one step. So what we're going to do is we're going to start with what we're given, 7.09 times 10 to the 24th atoms of helium. Our step 2 is still going to be the same, where we're going to bring down the units that we were given in step 1. So step 1, we had atoms of helium. So down here, we want to bring down atoms of helium. Now, the next step is typically to put what is unknown in the top of the fraction. But for this, instead of putting what is unknown, we're going to put the next step. So we started out with atoms. Now our next step is moles. So we're going to put moles of helium on the top. Now we're going to repeat those steps until we get to the end. So now we had moles of helium up here. We're going to put moles of helium at the bottom. So we're essentially repeating steps 2 and 3 until we get to the end. Now at this point, we had atoms of helium is what we started with. We brought that down in diagonal. We converted into the next step, atoms to moles, atoms to moles. We repeat step 2. We had moles of helium here. We're going to bring that down diagonal. So now the next step is going to be to put grams of helium on top. So that's how we're going to do two-step equations, is we're going to figure out the plan first. We're going to plug in those units. Now, if you notice, the units from your plan, atoms to moles to grams, which came from here, atoms to moles to grams, should also be the same as the units in the numerator, atoms to moles to grams. So all of that should match. Now, our very last step is going to be to put in the conversion factors. So what we have to look at here is this first fraction, we're looking at moles and atoms. Well, when you're converting between moles and atoms, you want to use this conversion factor that 1 mole is equal to 6.02 times 10 to the 23rd particles. So 1 mole is equal to 6.02 times 10 to the 23rd atoms. Now, for this fraction, we have moles and grams. So now we're going to use this conversion factor, that 1 mole is equal to the molar mass in grams. Now remember that molar mass comes from the periodic table. So 1 mole for helium is 4. So if you look at the periodic table, you want to round it to 2 decimal places. Now, to figure out the actual answer to this problem, remember that we're going to multiply what's in the numerator, so 7.09 times 10 to the 24th, times 4, and then we need to divide what's in the denominator. So 7.09 times 10 to the 24th times 4 divided by 6.02 times 10 to the 23rd. So once we figure all of that out, we plug that into the calculator. The final answer that you should get, rounded to 2 decimal places, is 47.11. Then remember your units is what you're looking for, grams of helium.